All right, here's a problem that is essentially getting down to the basic definition of pH, but it's also trying to remind you that there are strong acids and there are weak acids. And for strong acids, we can say that they disassociate completely when you put them into solution. And so that means for HCl, every bit of HCl that you put in the solution will disassociate completely into H plus ion and chloride. Now, in order to figure out the pH, we need to know the concentration of the hydrogen ion, because the definition of pH is to take the log of that and then the result becomes negative. So the negative log of the concentration of the hydrogen ion. And so in order to figure out the concentration of the hydrogen ion, you need both the number of moles of H plus and you need to know the liters of solution. And the liters of solution are given to you directly. 350 milliliters is 0.350 liters. Now, in order to figure out moles of H plus, we need to use the molar mass of HCl in order to sort out how many moles of HCl there was. And we know that for every 1 mole of HCl, we got 1 mole of H plus ion. And as you get really good with this particular exercise, you'll intuitively know that the ratio is 1:1. And so you won't need to write that step down, but I'm showing you just the stoichiometry now, just to make sure that we understand. We get 1.275 mole of H plus, and now I can directly put that into my calculation for molarity, and I get 3.64 molar. Now, most pHs aren't negative, because when you end up with a number for concentration, it's smaller than 1. And so the log of a number smaller than 1 will be negative. The log of a number larger than 1 will be positive. In this case, we could actually end up with a negative pH. It's very rare, but the correct answer here is that the pH equals negative 0.56, and that's the right answer for this particular problem. Okay.